Hello, my name is Aditya Rath, and if you had to decide tomorrow whether a player is underpaid, overpaid, or a bargain, what number would you trust? Today, I'll show you VSPI, a data-driven way to link on court impact to save salary using 3 seasons of NBA data clustering and regression. In the NBA, cap and luxury tax rules force the teams to squeeze the most out of every contract. Traditional stats, points, rebounds, assists, missed defenders, playmakers, and glue guys who impact hides between the box score lines. VSPI's goal is to translate holistic performance into an expected salary so front offices can compare what a player does with what a player costs. I built 3 aligned data sets across the last 3 seasons: salary, contract details, standard performance metrics like points, assists, rebounds, field goals, minutes, and etc. Advanced metrics like PER, win shares, PIE, VORP, and net rating. After scraping and cleaning all these data sets, I aligned each player's season stats to the correct salary year and dropped rows with non-meaningful minutes. I used a helper program, Data Helper, which I created, to convert messy text blocks into clean CSV rows. Exploratory visuals surfaced patterns and exceptions among top scorers. True shooting tracked well with efficiency, yet injuries created anomalies, like Joel Embiid, for example, appearing highly efficient on true shooting, but lower on total scoring volume in the same season. Looking broadly, salary does scale with scoring, but not cleanly enough to be our main signal. I tested linear and polynomial fits between performance and pay, then compared salary advanced stats like VORP and PIE to bridge the gap. The most strongest was VORP as it captured both offense and defense and normalized the playing time, which correlated best with the team's success. To avoid one-size-fits-all curves, I clustered players into 9 archetypes, from superstar bigs to superstars to defensive specialists and all-around role players. Within each cluster, I fit a salary curve that clusters VRP distribution. Quantitatively, VRP beat PIE by total MSC of 11.9977 versus 35.8439, a 23.8462 gap. Outliers are hard. Superstars like LeBron James are particularly prized by marketability and leadership, not just on-court estimates. So the model underpredicts their actual salaries. To keep curves realistic, I enforced a domain rule. VRP should increase with salaries and never fold back to the salary axis, earning those exceptions stabilized the fit at the extremes. The clusters capture role players in style. Giannis in superstar big men, Luca in superstars, and Alex Caruso in defensive specialists. This structure lets us compare like with playing a defensive ace against the right market, not against volume scorers. VSBI is a strong baseline, but it won't fully brand value leadership, minimum deal constraints, or cap quirks. Next steps include incorporating non-stat variables, endorsement value, roster construction, constraints, and trying to get more expensive models to handle better outliers. This same framework will extend to the NFL, MLB, and NHL, and even global football with league-specific features. Under the hood, the code loads the clean VSI, CSVs, computer features, clusters, outputs. In the demo run, I did show a mid-tier guard landing near his actual salary and a superstar unpredicted for branding reasons. Exactly where VSPI statistical scope ends and negotiation dynamics begin, because a guy like LeBron James, actual stats would value him around 35 million, but he's actually valued around 60 million with endorsements and all these other aspects of the game. VSPI gives a holistic, role-aware, and actionable estimate of a player's value by marrying advanced metrics with salary through cluster-specific curves. It's not a substitute for scouting or context, but it's a strong anchor for smarter negotiations and cap planning. Thanks for watching. I'm Aditya Rath. I'm happy to talk about data, modeling choices, and how to generalize VSPI to other leagues.